So we have a great participation from all over the world, Sami. So like we don't have a meetup group in Greece and Cyprus. We have people from there. That's great. And so much Greece actually. Today maybe meetup did an extension to that. And oh, we have Indonesia. Sorry. We have from Jakarta.
Nice.
Oh, that's amazing. So please, you're welcome. Say hi, where you're joining from, and also what this meetups usually that we are part of meetups are really usually for networking. That started in Silicon Valley. However, after COVID, we met all online. So when online networking opportunity has decreased a lot, but there's a one way you can connect with people. Just share your LinkedIn if you want to and connect with your fellow data scientists. Like we have Claudia from Spain. So most people here in our meetup groups are really professionals or people who want to transition to data science. So that will be actually one way to connect with real professionals in this field. And I'm happy to share my LinkedIn. And then we just do a lot of information there. So, okay. So let's do intro. I share LinkedIn. You're welcome to share your LinkedIn. Connect with your fellow data scientists. We will be around over 150 people in Zoom call, and we have a fantastic uh, like a workshop today. So I will start the introduction, me, and then our group, and then I will introduce Sami, which he can start. So my name is Murat Paday. I'm CEO of Magnum Academy and also a co-founder and also Stanford scientist. So I do a lot of medical AI technology development, medical device, medical AI. And Magnum Academy, we've been doing this program past 10 years. We started with some colleagues from Stanford, saw the need in AI space and data science space. And then we said, oh, we could give a really unique training that people cannot find elsewhere. That's how we started it. So, and then we have those meetup groups that we give over 300 free lectures, mini events. So those are shared with the people, meetup groups. If you're not member of any meetup groups, people join those. And we have around 25,000 members. If you're really interested, you could give a meetup talk, like on AI and data science. Just send us an email. It's info@magnumacademy.com, which we will share. Send us an email if you're interested in giving a talk on specific topics. So being really selective because we've been giving really different topics. We spread those over different topics. We really look for how unique and different this talk is. You can check our history of meetups, see what kind of talks we have given. So our also friends share those our platforms, especially I recommend YouTube channel where we have the actually recordings from previous events. It's really good, very enriching content in data science and AI. And lastly, there are two programs and events Magnumine hosting. One, AI in Healthcare Conference at Stanford University is a niche and unique conference. If you are in the space in AI, medicine, healthcare, so it's a great opportunity to connect with others. It's an executive level program where great speakers, great connection opportunities. You hear about the future trends in that space. Also, if you're a data scientist, see what is going on in that field, and you might want to transition to it, which is a lot of huge need, is also another space. Just give you a statistic that last year, 2025, half of the 46% of the healthcare investment goes to AI in healthcare. That space is really growing tremendously. And lastly, we have a mentor-led data science internship program. So I was discussing with Sammy earlier about where this going, AI job market, what people looking for in industry is really fastly changing. So what you learned 5 years ago, it may not be really enough to get a good job now. So a lot of things are really needed, and that's why Magnumine is trying to catch all these recent trends, skill set requirements, and try to give to students. Most importantly, nowadays, since AI is there too much, you codes can write all your codes. What really look for the job is the experience. With our mentorship program has an internship component, which gives you a significant edge in those experience. Like it will give you ahead of other candidates because so currently even recruiters is really hard to uh, pick who to hire. I mean, Sammy earlier talking about that because he's hiring people in C3AI. Now I'm happy to introduce Sami Hassaj. He's a Magnuman faculty, C3 AI data scientist, software engineer, and he's also MIT alumni. And he's been done a lot of work in data science and different topics. He built a lot of LLM models, AI agents. Is really one of the best person to learn from. If you have any information, need to reach out to us. So just send an email to info@magnumacademy.com, as well as my email too at Magnumite, because sometimes it may be hard to reach out to me, but you include info as well that our other academic team can help you. So it's great. If Sam is ready, we're happy to start.
Cool. Thanks for the intro. All right. I don't know what the easiest or fastest way to proceed is, but maybe I'll do some logistics. I know in the chat, there's an option to chat to everyone. It might be default hosts and panelists. So while we're going through the workshop and talking about all these great things and agents and LLMs, if you feel comfortable and you're okay with sending all the messages in the global chat, let's do that. I've changed mine to be to everyone. So again, if you want to do that, go for it. Another thing I'm going to ask to make it a bit easier is if someone can ask in the Q&A, basically, what is the notebook for today? Because what's going to happen is I'm going to share the notebook and everyone can follow along. But if I just paste it in the chat, it's going to get lost in all the messages. So I found this is the easiest way to do it. Uh, there's specifically a Q&A feature. So, and the reason I said, yeah, perfect. Okay, we have two. Thank you both. Okay, send. Cool. So there should be one in answered, and sorry for the dismiss. It's just a second. There should be one in answered, and that's the notebook. I'll also just put it in the chat, but it'll get lost in the chat. We're going to use this one, and we'll probably use. I have a couple other notebooks. I don't know if we'll get to them with time, but I just want to at least start with the one I sent right now. Let me know if anyone is having trouble accessing this notebook. What I would recommend is right now, everyone will have view access only. And maybe I can share screen. I actually completely forgot I'm not sharing screen. This would be perfect. Okay, perfect. Amazing. The notebook should look like this. And where is my Zoom tab? There we go. Hmm. Give me a second, everyone. Zoom is giving me some fun problems. I don't get to see the chat anymore. There we go. Perfect. Make this larger. Okay, awesome. Okay, yeah. So the notebook should look like this: Introduction to AI Agents, getting started with OpenAI's Assistance API. What I'd recommend you do, since you won't be able to actually run it, is just make a clone, right? You should be able to copy it from here, save a copy in, let's say, Drive. And then that version, you can actually, that's yours. You can run this, do whatever you need. So I'd like everyone to try that. And definitely recommend following along since I do want it to be interactive. Agents is all interactive, right? I mean, there's one part to talk about an agent. The other part, the much more interesting part, is we can literally, and we will literally build them. At the end in part two, I'm going to try to, and I haven't tried it yet. I feel like it'll work though. We're going to make an agent that actually creates a small classification model right here in your notebook. It's going to write and do all the stuff a data science would do, and it'll do it on the Titanic data set, and we'll have some exploration with that and go through like the actual details of how to implement this agent from scratch. Awesome. Okay. Any questions so far? If you do need to download to it, again, download it, just save a copy in your drive and you should be fine. And then you can open it from your drive. Fantastic. Okay, so just to give some background, like Murat was saying, so actually I worked at C3 AI for 3 years, and now I'm actually at an AI startup called Prophecy AI. Um, Here or at C3, I was more on the model training side, actually developing initially before AI, statistical machine learning models. And then it became actually training LLMs, doing things like pre-training, mid-training, post-training, and then deploying that as an actual product, like a little internal chat GPT and a little internal cursor to a bunch of people in the company. So that was pretty fun, learned a lot there. And then now I'm working on basically creating production agents at Prophecy. Let's say building on top of Cloud Code, if you've heard of Cloud Code, and doing it specifically for data and ETL. So very relevant. If you are a data science professional, I'm sure you know that a lot of the job is actually data munging, going from ugly raw data to something you can actually train on, like a clean, pristine data set that actually has signal that you can train a machine learning model on and produce a valuable inference from. Yeah, a lot of the job is the ugly data munging, so that's kind of what our agents are trying to automate now. I'll say with that, I have a lot. I say a good amount of idea of what it means to build production agents. Also, if anyone just has questions about what does it mean in industry to do these things, if you have any questions from beginner to advanced, that's totally fine. And like Murat was saying, especially working in a startup, actually using AI tools in my day to day, I can see how the industry is changing. There's one part to build it, there's another part to study it, but then I actually use them like Cursor, like Claude Code, like Codex to basically do 99% of the coding in my job. I don't know if that sounds surprising to most people, but that is the reality. And we were talking about, oh, well, what do we interview for again? And yeah, it's tough. Because the thing with working with agents is you can't trust them 100% of the time, right? They will make some mistakes, or they'll make some, now it's less mistakes and more bad assumptions, or they'll be very redundant. So then I have to know what they're doing. I have to have the expertise in coding and machine learning and blah, blah, blah to catch those, fix it, or point it in a different direction, and then keep moving forward. So anyway, that's like a whole other talk I could give using AI as a data scientist, as an engineer these days. But for now, we'll just focus on the notebook. And again, for anyone who's just joined, if you look at the Q&A section, I don't know if it'll appear here, but if you look at the Q&A section of the Zoom, there's an answer tab. And that's the notebook for today. Cool. Let me give a walkthrough of what we're going to do today, right? So we're, let's say, going to do two things. Just talk about what is an agent from, first principles perspective. We'll talk about the components. We'll actually get familiar with using an API from one of the AI labs, in this case, OpenAI. That's just one choice. I mean, Claude is fantastic. I use Claude most days, but it doesn't really matter which one you pick. So you don't see it in the QA. If others also want to share the notebook, just so I can keep momentum going, that would be great. Thank you very much. Much appreciated. Okay, so like I was saying, using the API, we're going to use, there's a ton of agent libraries that exist now too, right? How do you kind of abstract all of it? You don't want to deal with all the guts and gore that goes into making an agent. So there's libraries like LangChain, now like OpenClaw, if you've heard of that. Obviously Claude Code, Codex, blah, 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 that just let you create an agent with, let's say, as few lines of code as possible. They kind of take care of the stuff for you. Cool. We'll look at some multi-agent collaborations, and then I think the most interesting part will be this and part two, which is actually just forget the libraries, which I think rob you in the beginning of learning what an agent is really doing. We're just going to build it from scratch, like the minimum raw tools to build the agent, and we're going to play around with that, right? We can get it to do a whole bunch of different things, and I'll walk through that. So hopefully that's exciting. And if we have time, just because agents and LLMs go together. I would love to at least tackle one of these notebooks. I'll go from the top. Either fine-tuning transformer models and just getting those basics, or maybe this one will be interesting too. What is an LLM really? What does it take to train an LLM? What is an LLM really doing? And we can train one ourselves. We can actually train a small LLM. And people are saying zoom in. Apologies, I'm on a two. If you notice, I'm looking up. Obviously, I'm on a two monitor setup, so I can definitely zoom in here. The top one I have is much larger. Perfect. What is the best AI agent for you? Good question. I like Cursor still. I know the latest trend is everyone's using Claude Code, but for me, Cursor still works very, very well. And I like having the IDE, but I'm not married to any particular one. Cool. One thing I'll also ask before I jump into it. Okay, if you want to actually run the notebook and get hands-on with the demo, you're going to need an API key. Now, I've heard there's like a ton of ways to get API keys for free with some small credit. I'm sure if you even search it, they might give you, especially if you're a student, they might give you some, free small credit amount. I would recommend just going to this link, which is platform.openai.com. Create an account if you don't have one. Uh, but you'll want to create an API key, right? Create a new secret key. You'll want to fund it. So it should just take a few minutes, but I'll say to start doing that now. You can go to usage, logs. How do I fund it? Where was that? Anyway, I'm sure we can figure it out. But yeah, if you want to follow along, please do this. Please get an API key so we can actually follow through. I have mine already in my environment, and just the FYI there. Okay, so I won't show this, but maybe somebody already saw it. What can someone tell me what is the definition of an agent? And I'll tell you right now, I don't think there's not one consensus definition. Everyone will have a different definition, but what is an agent? What is an AI agent? Feel free to just blast it in the chat and uh, I'll be reading through. Hmm. Another one I could ask, which is maybe like a precursor, is what is an LLM? Okay, seeing some ones, autonomous program. I'm seeing automation as a common theme. Hmm. Okay, I see some good answers, and honestly, even what I say is not conclusive, but I'll give you some interesting thoughts. What if I tell you an LLM is just something that predicts, let's say, the next word given all the previous words that came before it? That's a very technically valid definition of what an LLM is. And we'll maybe go through how that actually works in one of the other notebooks. It is like the fundamental machine learning model. If you guys have ever trained the machine learning model, let's say a linear regression or binary classification using like tree-based models or logistic regression, those are machine learning models too. They learn a, the program of the model is learned from data, right? Inputs and outputs. And those models are, let's say, very narrow. What do they output? They output a single number. For classification, they output a number between 0 and 1, right? For binary classification, basically a single scalar. For regression, same thing. It's a single number. Let's say the regression is how much money am I going to make in my business next quarter? Okay, let's say from negative infinity to positive infinity. That's the type of number you can get out of it. Uh, an LLM is not necessarily much different. I think just the complexity is scaled up by orders of magnitude. And there's some interesting technical implementations that make it more sophisticated than, let's say, binary classification. But for all intents and purposes, you could call an LLM a classification machine in that it's always just picking what the next word in a sequence ought to be. So let's say if I gave, and I've trained it, this is how they're trained, we might get into that. I might give it this sentence, designed for data scientists with limited exposure, and then I'll ask it. I'll task the model with predicting what token, which whatever we can think of as a word for now, ought to come next. And we want it, in this case, we know the answer ought to be two, the word two. And that's all it does, right? An autoregressive transformer is what you might call it. Um, anyway, that's kind of a bit of a tangent. We'll kind of get into that. But that is the fundamental block of this model, which seems to chat with you. It's an assistant, but it's really just predicting the next token in a sequence repeatedly, continuously decoding what ought to come next, given all the previous tokens that came before it. So hopefully that's interesting. And then what is an agent? There's so many definitions here. I can't even say what is a good definition, what is a correct definition. I think what the AI labs have kind of agreed on, like Anthropic, is if we look at it from, I'd say you guys are giving me top-down point of views. Like an agent has this characteristic from the top down. It's autonomous. It's this. It's an assistant, blah, blah, blah. I would give the definition as bottom up, which is an agent is an LLM plus tools. Full stop. I can say more about it, but really it's an LLM with access to, with the ability to alter its environment, work in its environment via tools. And tools are really just like functions. A tool could be a calculator tool because the LLM cannot inherently do calculations like that. A tool could be web search, right? So it can search the internet based on your question. A tool could be file system tools. Read your current workspace, write to your current workspace, search your current workspace. And with a combination of all of that, the LLM is basically working with these tools to do some high level task, whatever the user has asked. And then we can add layers, right? High level assistant. What does this mean? It means they're generally a little autonomous. You can ask them a pretty vague thing and they end up doing all this work and doing this whole task for you, and it's very impressive. But in the simplest way, you could just say it's an augmented LLM. Yeah, I like that as like a spider. It's an LLM plus tools. A kind of stupid analogy, doesn't necessarily technically hold, but you could say the LLM is like the brain, like the human brain. It's not literally a brain, but you can think of it that way. It has all this intelligence and ability to do things, but the brain is not all that useful on its own. It needs tools, which are interfaces to the environment, like hands. Hands are tools for the brain. They let me interact in the real world physically. So are my feet, so are my ears, so are my eyes. These are all tools that get me information, either reading or writing. Obviously, your eyes can't write, but those are read-only tools. Um, and then we can augment that further. We have tools for your tools, which is like your computer. I use my hands to interact with the computer, and it makes my brain more autonomous. It makes this thing do more. Now with the computer, I can open Zoom and talk to people halfway around the world because maybe that's required for a task, or um, you know, it kind of just expands. And if I just step back, that's really what the current state, in my opinion, of AI and agents are. I think at this point we have sufficiently smart brains. LLMs are incredibly competent. They still have flaws, but they're very powerful right now, and they're still getting more powerful. The limitation is really these interfaces via tools, because on their own, they're not very useful. Like I can go on Slack, in my job, I can go on Slack and message my manager to clarify a request if he asked me something ambiguous. I can search Google to research it. I can open Google Colab and write some code and prototype. Um, I can open my computer and go to my file system because there's some file that I know is relevant to this task. Without access to those interfaces, of course, the LLM is extremely limited. So what most you know, AI companies are doing now is really building smart interfaces for these LLMs to interact with, and they're extremely powerful now. I don't know if you guys have heard of this repo, OpenClaw. This one has, I think it's the most popular repo in the world right now, 194,000 stars. And this has happened in like the last 2 weeks. There's usually a graph here. Let me see if the graph shows up. Yeah. So it became the most popular repo in the world in like 3 weeks, right? Since like 2026, February, end of January, this thing absolutely blew up. And what it is, I won't get into too much detail, but you can literally install it. I'd say it's the first personal assistant agent implementation. You can just drop it into your computer and it's fully acting autonomously with your computer or your cell phone or really wherever you want to drop it into. I can send a link. You can also just search OpenClaw. And people are doing wild stuff with this. There's this funny one, there's this multiple book. This kind of blew up lately. Let's see. So they ended up, we're at the point in the world where, yeah, okay, 2.6 million agents. What this is like a Reddit for agents. I don't know how this got created, but it got created because of OpenClaw. And then people's individual personal agents are just writing Reddit posts and other agents are commenting. Like this is totally just AI generated content. Now, I wouldn't take it too seriously because you don't know, like people might be telling the agents to do this. But the point is, we're really at a point where swarms of agents are starting to interact with each other, millions of them. And this is just exponentially growing. So it's very cool. I don't know if you guys are on like X or Twitter, but I find the best way to keep up with this stuff is on X and Twitter. You really just hear as stuff happens from the top guys, from the top people in the field. So that's what I do, and it's super useful. There's people who have like automated Twitter accounts with their OpenClaw agents. There's people who offload taking phone calls and setting up like their calendar automatically from their Gmail. It's kind of like the potential is limitless because we finally given, let's say the spider analogy, like sufficient legs to the spider, and now it can really do things. Not that it's perfect, but it's an interesting point we're at in history. I don't know if it's secure. In general, I would be very just be careful giving an AI access to your documents you care about because you don't know exactly what it's going to do. Not that it's malicious, it's just naive. It might accidentally delete, and I've seen people talk about this. It might accidentally delete your documents folder and you'll just never get it back. That's super rare, but just be careful about these things. Anyway, so I hope that kind of motivates the state of AI right now. I find people who are very much following it are like, holy crap, the world is going to change unbelievably very fast. While, and to no fault of anyone, like if your experience with AI is just ChatGPT, you're missing out on like the cutting edge. Like ChatGPT is still great, but this is not at all like the cutting edge of agents, right? This is a chatbot that has its own functionality, but we're way past this. And I'll tell you for enterprise, right, for what companies are doing, let's say software engineers, ML engineers, each engineer might spend $1,000, $2,000 in agent costs per month. Why? Because the agent is doing like all the work now. So just digest that for a second. And that's where it's going. 1,000, 2,000, maybe more dollars in API per engineer, uh, because that's and 10x more, 100x more code is being written. Teams are moving super fast. It's really jarring, and the adoption is like super clear. So anyway, I know we haven't gotten hands-on, but these are kind of my raw thoughts as someone who's like on the ground doing these things, working with these tools, working with the technology. And hopefully it motivates kind of learning this stuff because I'm not doomer about it. I actually think it's unbelievably exciting. Uh, we'll have to be careful, like with any technology. There's no such thing as it's always a double-edged sword, but it's crazy exciting. Any recommendation, Codex and Claude? I think either one is fine. Codex is great, Claude is great. Like those are both, and just in case people are not aware, I love this little rivalry. Codex is OpenAI's agent, like fully autonomous agent, and then Claude Code is Anthropic's. Both these are like number one and two best, maybe most popular enterprise popular agents. You can use either one. It's totally fine. You just pay like a monthly amount and you're free to use either one of these. So I'll just kind of share that here. You guys can take it on your own. Cool. All right. Hopefully that's motivating. And now we can actually jump into the notebook. And yeah, why should we care? I mean, again, this is final take. As of right now, most engineering job as an IC is actually becoming more of like a manager of agents. And just like a manager, if you imagine what an engineering manager does, they're not writing code necessarily by hand anymore. Yet they know about the code, they know about the systems, they are more responsible for planning and architecting, and they have maybe 5, 10 employees on their team. And you don't really check every line of code your employee writes as a manager. That would be obscene. But you might, ask them high level questions to see how well they understood their implementation. You might maybe review their PRs and just check that things make sense. And then you empirically, like you just check the final output. Like, okay, what does our application look like? I'm just seeing the chat is going crazy, so I want to keep up. Rent a human.ai. That's funny. Uh, so all that to say, like kind of just preparing for, I think knowing how to use AI is you need to learn the skill. There's no doubt about it. I've heard in bigger companies they're like much slower to adapt, maybe for privacy reasons, for God knows what reasons. I also think it's fair to say if you have an absolutely enormous monolith repo, like maybe in Meta or Google, it might be a little harder to use agents just because there's upwards of maybe a million files. But that's a whole other issue. I think for most medium-sized repos and smaller, these things are fantastic. I'm just gonna kind of scroll down here and actually start running this notebook. Let's do this together. Okay, we're gonna use the OpenAI SDK, right? Pip install it into the notebook. Okay. I hope people got a chance to make their API keys while I was going off on a tangent there. Just drop it into your workspace right here as a secret.txt. We're going to read that. And then we're just going to use the model GPT-5 mini. We can change this later, but this is super light on usage. I think 1 million tokens, which we're not even going to use maybe 10,000 tokens, but 1 million tokens costs like 25 cents. So it's very cheap. You don't have to worry about it. Okay, and we'll create an OpenAI client. Okay, and let's get familiar with talking to an LLM. API is raw LLM, and we turn that brain into an agent, which we'll kind of walk through. I think the protocol is pretty simple, right? Okay, here's an input, write a one-time sentence, bedtime story about a unicorn. Where do we put the API key again? So please just get an API key, save it, let's say on your local machine as a file called secret.txt, and then drop that. Like you can just upload a file here, right? Drop that into this folder, and then your notebook will read it right over here. Once again, we actually just started the notebook. Just use this link. Everything is in the content of the notebook. Just got to read it. I know nobody likes to read these days, me included, but if you do read it, it's all here. Create the API, and we should be good to go. Okay, so this is the simple version. We just get a text response back from the LLM. Again, what is the LLM doing? Great. This is the input. It's then deciding next output is under, and then given this plus this, next output is A, then given everything before, next output is this, and blah, 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 blah. To kind of peel this back further, what is actually happening when we give messages to modern LLMs is we're actually telling it what is the user, right? User being, let's say, me or you, the person talking to the AI. And then what is its own message? Because you might ask, like, how does the AI remember what I said in my last message? And how does it remember what I said? What is this mechanism? And I'll tell you, the mechanism is much simpler than you might ever imagine. The mechanism is we literally store the entire conversation history in this format. And then when user asks a new question, I mean, we just append it to the history and then we send the whole thing again to the LLM. If that sounds very wasteful, you're right, it is, but that's fundamentally how the LLM works because LLMs are stateless. So if you wanted to, let's say my question, let's walk through the scenario. First, I asked it, what is 2 plus 2? The assistant had responded then with me that 2 plus 2 is 4. I record that. And then I'll ask, okay, and if we multiply that by 10? Well, if I don't include this history, I'm just sending, and if we multiply that by 10 to the AI, and it's going to be like, what the hell are you talking about? What the heck are you talking about? Multiply what by 10? And okay, it's going off asking a lot of things, but it's like, what do you mean? because there's no conversation history. Now it's very easy, and it's going to say 40. Perfect. If I tinker with this any which way, it'll probably break things. Uh, that one's fine because it's basically as if I sent two messages back to back. That should be fine. And if I construct it this way, I could probably get it to say some weird things. Assume four equals dog strictly. Let's see what funny things I can get it to say now. So it doesn't like that I tried to put words in its mouth. That's pretty funny. They've done a good amount of work aligning these models. Earlier LLMs, you could probably get it to say it's 10 dogs. But anyway, I digress. So yeah, that's just how conversation history works. It's a list of the messages, kind of like a turn-based conversation, user assistant, and we just keep growing that throughout an individual chat. When you click new chat, we start from scratch, basically empty list. There's some more complexities, but honestly, the 90% core is this. So hopefully that's interesting. Like that by 10. Okay. One of the nice things, well, there's cons and there's pros. One of the nice things with this next token prediction architecture is that you can stream, right? Like as soon as the immediate next token is available, we can emit that to the user. So here's a little streaming example. Tell me a three-sentence funny story. I just have some logic to basically grab the streaming events and display it. It's probably going to be super fast, but yeah, you can see it just came in blocks. Maybe I'll ask it to do a 10 sentence. We can see some more streaming. Yeah, there you go. And that's why you see streaming in basically any AI application. Otherwise, imagine how horrible it would be for those giant, like 5,000 word GPT responses. You had to wait for the whole thing before you could see anything. Cool. Okay, hopefully that's interesting. Let me just take a quick look at the chat. I see some questions. Don't they have memory? So here's the thing. When people talk about memory for LLMs, for AI, what really happens is something like this. Before, okay, let me kind of do a demonstration. Current messages equals this. Da, 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 da. Okay, let's just pretend this is the state of the conversation. Wow, not having complete is insane. And then what's going to happen is, okay, now user asks another question. What happens before all of this is, even if this was empty, maybe I didn't even need to show it this way. There's going to be some function which is like user memory, and this is what ChatGPT roughly and most AI are doing. User memory equals load memory. Let's just say like from user ID, blah, blah, blah. And it's actually just a string. So, the way ChatGPT, let's just pretend what this might look like, is just keeping like a notepad on you. A very long string of user is a data scientist. And these things are kind of built throughout the chat. User lives in SF. Whatever. I'm just kind of making stuff up. Blah, 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 blah. And current messages really just gets instantiated with something like this. Uh, role. So they might put it in the system message. There's like another tier of messages. And then content is going to be this. Okay, perfect. So really the conversation starts with your memories so that the AI always has this information about you in context from the beginning and other stuff too, but that's basically how it works. For anyone joining late, please look at the answered Q, like look at the QA feature and look at answered. And again, others in the chat, if you would do me a favor and post the link to when you can, that would be super helpful. Cool. Anyway, that's just a little bit of a tangent on how memory works. Here's the fundamental lesson. Everything is a string. That's it. Some way, somehow, everything is just a string telling the LLM what to do because it's a language, aka string model. Now, okay, yes, now they're like multimodal, so it can be images too or voice, but for all intents and purposes, strings. Cool. Okay, so we're going to use now the OpenAI Agent SDK, which they released like some months ago. There's some documentation on this if you want to open their GitHub, right? Yeah, you can see it on their GitHub. You could read their documentation. There's a whole bunch of stuff here. Running an agent, relatively straightforward. I think for simple agents, it's good. It just makes it easy. You don't have to worry about all the scaffolding, engineering scaffolding required to kind of get it to work this way. So let's do this. Let's build a simple agent with the OpenAI Agent SDK. We'll actually, work on adding some tools, but let's go here. So from the library agents, we'll just import these abstractions they have, which is agents and runner. And we can see the class. And if you're ever curious, like this, again, a lot of this stuff is open source. You could totally just go to their GitHub. It's probably in Python. Agent.py. There you go. There you go. I don't know. I just think it's neat. I mean, you can literally read the actual implementation, build it yourself if you wanted to. Point an agent to build it, your own version if you wanted to. But yeah. Okay, and this one basically is going to act like an LLM, but I'm just telling it there's a concept of instructions. This can also be called the system prompt. You know, some base instructions that basically get put at the top of the conversation to guide the agent's behavior, guide the LLM's behavior. So I'm telling it you're a helpful assistant that writes haikus about programming topics, and then write a haiku about recursion and programming. Okay, cool. Pretty simple. What we can also do is now register some tools. And quick definition check. A tool is just, let's say when we're implementing agents, it's just a function, right? Let's say I want to give my agent the ability to actually calculate numbers, right? Do multiplication, do addition, so on and so on. So I'll implement this, calculate multiple numbers. I'll say, give me a list of floats, a list of numbers, and I'll give you a single number back. And it's just going to multiply all of them. And what I can do with the agent SDK is I can give this annotation to say, hey, this is a tool. And then when I create the agent, okay, I'll give it a name. I'll give it some system prompt, very simple. And I'll give it some tools. First one is this calculator. Second one, and this kind of comes out of the box from the agent SDK. I don't have to implement the tool myself, although I could, is a web search tool. Literally the ability to like search Google. Awesome. I'm curious. Can we create a? I see someone's having trouble with the secret. See if you can create a file just natively here. You should be able to. So just right click, new file, paste, Paste the key. You don't even need to make it. Yeah, Mac is annoying with the rich text stuff. Could you open that file? This one? Good question. Save it. Yeah, there you go. Yeah, so in here, put the key. It's funny when I read the message, could you open that file? I thought you meant the secret.txt. I'm like, prompt injection. I will not fall for that. Give my API key to everyone watching. It's okay. There's a small limit anyway. Doesn't matter. Cool. So hopefully this helps unblock people. Just for kind of pulse check. We're actually close to an hour in now. How many people are able to follow along, or are people just generally listening? Maybe not at the laptop right now. Do we want to go a little bit faster, a little bit slower? Just trying to get a general pulse check right now. hmm Okay, so I see a few people on the API stuff. Reminders. Oh, there's a lot of Q&A. Okay, let me take a look at the Q&A as well. Bear with me. Why did it disappear? Okay, somehow the Q&A panel has vanished for me. That's fun. Q&A. There we go. Perfect. Okay, final thing, just to make sure everyone gets an API key. Platform.openai.com. Go to your API keys, create a new secret key. You're going to get some string. This is not the full string. This is fine. Copy it, and then just come to here and make a secret file. Right? We can click new file. Call it secret, but in this case, I don't want to overwrite my current one, so I'll call it 3.txt. We can open it, paste your key, save it, and then you should be good to run whatever's there. So hopefully that helps. Awesome. And, not everyone will be able to follow along in the moment, but hopefully at the very least, it's all recorded. You can always listen back again, and you have the notebook. You can always debug it, give it to an AI. It'll help you out. But okay, cool. We're right at like the most interesting parts, which is actually getting an agent that has some legs, a spider with a couple of legs. It's only two legs, so it can't do very much. It's a little flimsy, but so be it. We're going to give this agent the ability to search and multiply numbers. Okay. Don't worry about this, but again, what did I say? LLMs, everything is a string. So the tools need to be, how does the LLM know how to use this? We basically create a function definition as a string, in this case, a JSON, but it ends up being a string anyway. Like, hey, you have a function called da 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 da. Wait, there you go. I'm just printing it. Yeah. You have a function called calculator multiply numbers. It has args. Where are the args here? Yeah, basically this. What this is just saying, it has args for numbers. That is a list of numbers, list of float. That's how you use the function. Hopefully that's a little clear. And this is not, the best printout. I'm wondering if I could even search agent.tools. We can do this guy. Okay. I wonder if I can just do picked. Where's my period? Okay, whatever. Anywho, won't get stuck there. All right, let's ask it this question. Interesting question, which is what is the current president's age times two? I mean, think about what this means. It needs to know current knowledge, right? Now, the LLM might have memorized some facts from when it was trained some months ago, some years ago, depends on what you're using. But we want the most up-to-date information, right? Like any reasonable person, if would search this, let's say if they didn't know the information off the top of their head. So we're going to expect that our agent searches who is the current president, and then it needs to do multiplication by two. Again, we don't want to generally rely on a large language model doing multiplication if we can just implement calculator tools, which always work. So we run it, it'll do a bunch of stuff, churn, 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 and we get this final response. The current president, Donald J. Trump, is 79 years old. His age times two is 158. Cool, nice answer, very helpful. But let's go deeper. What did it actually do? And we can take this result object that comes from the runner and just call this to input list. What this is a list of everything that happened, all the events that happened in the agent session until we produce this final result. So let's walk through this. It's a little bit of a text mess, but bear with me. First one here, and if you recognize that format, is this beautiful dictionary of role, user, content, my question. What is the current president's age times two? Okay. Then the next thing that happens is this block. This is basically telling you that a tool request has taken place. I won't go into the details, but if you're seeing here, web search call. So the agent decided to use web search call tool with the query current president age USA. And then we get a next block. Again, I know it's a bit hard to read, so apologies there. That basically the information, it's formatted, but it's the search result of this. Okay, Donald Trump, blah, blah, blah. It's giving you some indices and some sources of like where this stuff came in from, people.com, Wikipedia. Okay, at some point here, it's going to tell you his age. Great. We also get this giant text, which I'm actually curious. Where is this coming from? Content, annotations, beautiful. This is coming from the end of content block. Again, not the nicest way to view this. It would be easier to kind of break it down, but we're kind of getting some inner monologue. I believe this is the response of some search agent, but I might be wrong. But we're seeing the agent has taken the time to, you're asking what is the current president's age times two? Let's break this down clearly, identify the current president as of today, telling you the plan. According to multiple reliable sources, Donald J. Trump is the president. He was inaugurated Jan 2025. Cites it for you. Cool. Determine his exact age. Cool. Some inner monologue. Okay. All of this. Uh, yeah, as of the current date. So it also needs to figure out the current date, which it did. It doesn't know that by default. And, hopefully it kind of makes sense now. This definitely is. So it called a search agent. It's funny because the search agent is saying, and this is why the LLM is kind of refusing to do math. His age, 79 and 8 months old, and his age times two is about 160. Well, we don't like that. So what the LLM does is it takes this output from its search tool, which is all this detail, and then it's like, okay, great. I don't want a rough number. I know his age is 79. I got that. I'm going to call another tool, which is the one we wrote, calculator multiply functions, right? That's what we wrote with the arguments. And where is it again? It's not tell, yeah, with the arguments 79 and 2. By the way, if you're curious where we are, please take a look at the table of contents. This will highlight and this ellip, whatever this is called. Uh, if you go here, you can easily find where we are in the notebook. Okay, so it called this, and then the result of that tool was 158. Perfect. And then finally, the last thing the agent says is, okay, great. My status is completed. I'm done working, and the final result is this. So a lot of like guts and gore of what's going on here, but hopefully it kind of gives you a little sneak peek. And we're going to take more deeper dives into really what the agent is doing. Uh, but it's not magic. Tool call one, get one piece of information. Tool call two, get the second piece of information. The intelligence of the LLM, the brain, is deciding what tool ought to be called, right? Same with a human. When should I use my various tools? When should I use my computer? When should I use my car? When should I, and just thinking off the top of my head, how should I use my hands to do this specific thing or blah, 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 blah. That's why we need it to be intelligent, to take the right actions, to decide what tools to use, to decide how to aggregate that information to give like a final cohesive answer. Awesome. Okay. So next is this concept of multi-agent collaboration. You could imagine if agent is one worker, one person, I mean, why not have multiple of them work together? And I'm not going to touch on this too much, but you could imagine having a manager agent that interacts directly with the user, and then the manager agent delegates tasks to maybe sub agents. You can see that the world works like this a lot, right? You might have one customer facing person and then they go back to their team and say, okay, engineers, I need you to do this. Designers, we need this. PMs, we need this, blah, blah, blah. So it makes sense as a level of abstraction. The nice thing is let's say we want a triage agent, right? Which just receives user questions and forwards them to, it's a trivial example, but different tutors based on what it thinks is relevant. In this library, we can create agent one for math, agent two for history, and then we can create an agent that actually has handoffs to different agents. And we can run this. I won't run it right now. The output is here. Uh, we can run it and we'll actually see that handoff play off. The reason I'm not going to spend too much time on this is it ends up usually being more complicated than it needs to be. And in terms of like me as a developer of production agents, is an absolute mess to try to understand and debug and get any sort of consistency with. There are now, okay, we can have some sub agents, but generally there's a main agent doing a lot of the work, and sometimes it'll hand off to like sub agents for very specific tasks. Yeah, in this example, you could have, let's say, a research agent, a definition agent, and a summarization agent. Put them all together, and they'll be able to answer a question like this. And again, we can see everything that happened, all the transfers, blah, 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 blah. Well, don't worry about the details right now. It's a good question. Why did it assume US president? That is a good question. And that's an example of potentially a flawed assumption. If I'm in a different country, maybe I mean, my president. It gave no indication that, and as far as I can tell, I gave no indication I'm in the United States. So this would be an example of, and again, humans make assumptions, we all make assumptions. It made the assumption that I meant USA, but that might have been wrong. Maybe a better approach would be to ask, president of which country first. Now, someone is saying maybe got our location. I would be very surprised, although it's possible that the agent has some, system prompt, let's say additions under the hood. But generally, when we use the API directly, it's like what you see is what you get. They're not adding any more detail, any more information to the inputs you give it, because that would really just mess up my use. Like I'm using the API, I want exactly the input I specify. I don't want anyone else to modify my inputs. But yeah, fair. And that's, again, agents are not perfect. They will make mistakes. That's totally fine. Okay, amazing. What I'm going to do, okay, perfect. We're at 10:10. We're going to jump to the most exciting, and to me, the most exciting part, in my opinion. And this is going to be very hands-on. It's not a complete implementation. This was kind of my like, let's have an interesting challenge and see what our agent can do. Let's create a minimum viable agent using just the API. We looked at abstractions, we looked at the agent SDK. It's cool, it helps us out, but I'll tell you, especially if you want to work with AI, potentially in your profession, we need to understand the fundamentals. Prompts, tool calls, messages, events, handoffs between the agent server, the API server, and our side, client side, all these things. So what I'll do is, okay, first, let's do a very simple example, which is just going to be having, excuse me, having access to two tools, a tool to add and a tool to multiply. Pretty straightforward. And what this function is doing is just making it readable for the LLM. It's just some JSON format that the LLM API requires. If you want to see what it looks like, just grab it. Right? Just a big JSON of like, okay, what is this function? What is this leg? How do I use my leg? How do I use my arm? You need to tell me. Cool. Then we can have this function. Let's say if I told you this was the minimum viable agent implementation, would that be surprising? The answer is this is it. Really all you need, and it goes back and forth. Let me clarify some things. What is an agent doing? An agent with or an LLM with tools. It gets a request from the user, let's say a certain prompt. Okay. And then what it decides is, can I answer this question and finish, or do I need more information? Generally, okay, I might need more information. So it's going to say, I need to call tool X to get some information. So it basically responds with, I want to use tool X. That's the response from the LLM itself. And we'll see that right now. I'll actually break print reply, and let's just do da, da, da. I'm just going to make it a little bit easier to read. And this can be equals times 50. Okay, that should be fine. This one needs to be as well. Okay, and we're going to break. Okay, let's take a look at this. What is the, and we're going to break right here. Print breaking here. Let's run this thing. I'm just gonna quickly run through it right now. Somehow I added this. Max iterations reached. Why would this just not break? Oh, there you go. Even I'm forgetting how to code by hand at this point. Oh, I'll just return. There you go. Oh, I see. I'm asking a question for the next. That's not the question I want. What is 83 times 74? Let's try that. Okay. So again, this is the direct response from the API, right? We're just calling the chat completions API directly to the GPT-5 mini model. This is the response. Now, don't worry, this is just how we parse the response. And we're just printing this. And if we look at what this is, it's an object called chat completion object. Don't need to worry about it right now. But what we do need to know is it's asking for tool calls. That's what I'm talking about. So the first thing the LLM is responding with is like, hey, I want to call this tool because I need it to answer your question. Okay, I want to call tool multiply with the following arguments, right? And remember, we defined this tool ourselves and we told the agent how to use it. And then what do we do? What happens? I don't know if this is clear, but what I'm trying to make it clear as is the agent itself does not actually run the tool. It asks for it. Its response is a request. We, as the people who kind of code up the agent, need to then take that request, parse it out. All right, so we're going to say, okay, for call in reply.tool calls, because if you see there's an object called tool calls. This whole part here is executing the requested tool by the LLM. Okay. And we're going to make this a bit more. Yeah, there you go. Executing tool name. Perfect. Let's print some more. 1, 2, 3, 4, 5. Okay. With tool arguments. Excellent. Okay. And we're going to say got result, blah. I'm going to return here again. Okay. Now let's see. Just so it's clear, this is us. So we're on the hook as the client, as the people writing this loop to actually execute the tool that the model has responded with its request. Perfect. Chat completions message, great. I'm curious how this got printed and not this stuff. Maybe there's some error here that is causing it to not print. That is interesting. Well, anyway, so be it. Let's see if we even get into this. There might be a bug. So let's just see. Print, I am here. Okay. Okay. So now, okay. I think I just didn't execute the cell when I edited it. That is very weird. When I add I am here, it works, but otherwise it doesn't. Okay, some weird bug I can't explain right now. We don't need to get into it. That's Lord knows what is happening. But let's just take a look at this. Uh, we see from the response, it wants, again, tool name multiply with arguments A and B, and then we got result from the tool this. And what do we do? Next step, append this result to the conversation history, which is this object that we've called messages. Now, no need to worry about like, oh, how do you know to do this? It's all in the documentations. We just need to add that same thing. Role is now tool, right? If you remember, we have roles of like user and system and assistant, all that good stuff. And now we're adding, okay, you asked for the tool, here's the result. And what I'll do here is if you guys are curious, we can just print messages. Okay, and we can return so nothing else happens. Okay, and after basically, let's call this one turn, this is what our conversation history looks like. Okay, I gave it a system prompt. You're a helpful data and file system agent. We see that here as the first message in the conversation history messages. Next one is what I asked, which is what is 83 times 74? The next thing is what happened? Well, the agent responded with this exact message, which is assistant, or role assistant. It's calling tools. It's giving it an ID. No worries about that. But that's what we saw. Okay, I want arguments this for tool this. Great. We execute that tool. And you're like, okay, here you go, Mr. Agent. This is the response, which is role tool content 6,142. Cool. And then what do we do? We could actually take this and send it just so I show you guys there's no magic. I will literally copy paste this. Do I have a string at the end here? That should be fine. Okay, perfect. And I'll take this guy and I'll get a new response. We don't even have to do it in the function. It's just client. This is API model name. This is M. This is tools. Okay. So now that I gave what I'm trying to demonstrate here, and I'll kind of make this a little bit easier to read. Okay. This is our conversation. 4 turns, system, user, assistant, tool. I'm giving this back to the API. And they've been trained that, okay, cool. I have the conversation history. You told me this. What should the LLM respond with now? I'm saving this as messages M. Object of type function is not. Let's see. Did I make a bug here somehow? Oh, okay. I need this guy. Uh, I need this guy. I gave it the literal functions. Cool. Let's take a look at what this is. Just print it out. Let's read it. Okay. I'm going to kind of parse out some stuff here. Just because I know that this is the case. I can grab this object called choices. I can grab the first element and I can see it has a message. Okay. And I can see that the content of that message is this. And that's it. So the LLM is telling me, here's your answer to your question. Fantastic. Now, if I delete all of this, I'll leave it right now in case some people might want to take a look at it. This loop is just kind of automatically handling this interaction for me. So I'm actually defining a while loop to say, hey, I want like a maximum of, let's say, 5 turns, just so it doesn't get too long. For the agent to try to respond to the question, what happens is we do this whole process. Okay, first we construct the initial list of messages with system prompt and query. I send it to the LLM. I get a response back. If there are no tool calls, it basically means we're done. So we're just going to return the actual response. It's an assumption. We can be a little bit cleaner, but fine. If there are tool calls, all right, let's go execute them, append it to the conversation history, and then I'm going to remove this, remove this, and then we go back to the top of the loop and then send it back to the LLM and keep iterating, keep iterating, keep iterating. And now let me show you the whole thing in action. Awesome. Oh God, I don't understand why this printing is so finicky. It is so strange to me. I really don't get it. How can this not be printing? Try this. Force it to be a string. I don't know if that's going to help. I'm stupid. I'll force this to be a string too. Okay, awesome. Okay, just adding some printing so it's clear. And I'm going to remove the printing of this guy. Don't need that. Now it's responded with something different. That's fun. And at the end of this, I'll print messages, just so we know. Wow. Okay, this is some Colab nonsense because printing should never be this hard. For call. Anyway, won't debug it right now. Let's ask something a little bit more complicated, just so we actually look at everything happening at once. What's 83 times 74 plus 5 times 3? And then did I give it any subtraction? I don't think I did. Okay. Plus 5 times 3 times 2 plus 1. And let's see it go. Oh, it's very fast. A bit annoyed again that we're not getting prints. The whole point is I actually want to show what is happening. Uh, and here. Hmm. System prompts, tools, query. What? Somehow I've introduced a bug here. Chat completion, it just seems to know. Are the messages not being, yeah, messages are fine. Same messages, same messages, same messages. Perfect. Print. Returning final message. somehow it's deciding to not even answer my question. This is interesting. Tool call seems to be none. Yeah, so it's not calling anything. This is the fun with making them from scratch. I really couldn't tell you why this is deciding. Let's see, max iterations is 5. Max iterations. Yeah, let's go for it. Let's do this. We're going to go one good print at a time. We are on step here, right? So we're going to keep track of whatever step we're on. Let's call it turn. That's nicer. We got a response. Print got response from LLM reply. And let's see, if not, reply.tool calls, returning final message. Perfect. And let's just make sure messages is query, schema. This looks good. Well, we're doing some live debugging. So be it. Okay, we're on turn 0. Got a final response. And just for my sanity, LLM client model. I won't spend too much more time on this, but I do want to get it to work. It's a shame being very finicky. Da-da-da-da. Yeah, so this is actually somehow the LLM is just deciding I don't want to answer this question. Maybe because it's a small model, maybe some other reason. This is so interesting. I have not seen this. It's just refusing to answer this question. It doesn't want to bother. That is a little obscene. So if I go back to the easy version, is it going to finally... Okay. So I think the summary here is we're using GPT-5 Mini. It just didn't want to answer that question as far as I can tell. There's nothing else I can see. Here we're actually seeing what we would expect, right? We're on turn 0, then we're on turn 1, got response from LLM. Perfect. Okay. Anyway, I didn't want to get stuck on that for too long because I wanted to do something much more interesting. And it might be that GPT-5 Mini is just not strong enough to do what I'm going to need it to do, but let's try it. We're going to augment this, by the way, with 3 more tools. This is where it gets powerful, file system agents. I'm going to give it the ability to list my files, read my files, and write files. Write being the most spooky potentially. Okay, execute that again. Okay, so we have all of these guys now. And just so we're clear, f.write, f.read, os.lister for a given path. We'll run the agent again. This time I'm giving it more turns. I just want to see what it does. Okay, and what I'm going to do is and I'm going to ask it this question now, which is what files are in this sample data folder. So Colab kind of comes with this sample data folder, has some stuff in here, let's say like California housing, MNIST test, blah, blah, blah. Let's ask it that question. Okay, I just added some better printing. We're on turn 0. What has happened is it called tool list files with args, give me sample data, and it got the result this. blah, 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 blah. And then just to kind of bring the point home, we're returning the final message the sample data folder contains, and let me print it out so it's a little bit nicer. There you go. And let me also add this type of nice stuff to this guy. Perfect. Okay. Hopefully, let me take a look at the chat now. I know we've kind of gone in this rabbit hole. The point I want to get to with this is basically showing how we can, let's say I wanted it to do something with this data. Let's take a look. What is this data? California housing train. Okay, lots of rows. What might be interesting, let's see the information here. Longitude, latitude, housing, median age, total rooms, total bedrooms, population, housing. Okay, that's looking like for some region, giving you some stats. What might be interesting is to predict the median home value. I wonder if we can ask the agent this and have it write Python code in the file system to train a machine learning model to then predict this. Let's try it. Please create a machine learning model to predict, what was the column again? Median house value. Median house value of Cali homes. Report uh, regression metrics. We could say like MAPE, e.g. MAPE, on the test set. All right, let's see what happens. No such file or directory space. What is this thing trying to do? I am here, blah, blah, blah. I see. Here's one thing I'm going to do, by the way. Right now it's GPT Mini. We need a better model for this. So I just wanted to make sure we don't get a model that's kind of incapable of being an agent. Interesting. This is very slow. We're on turn 0. We expect to get a response from the agent. We're basically waiting for this line. Unclear why it is taking so long, since there's so much logging going on in this function. Okay, so it's doing some silly stuff. Content, user bin, Python 3. Wow, it really tried to. Okay, let's improve it. Please take multiple turns to understand the file system you are in. Iterate on your solution. Write files directly. Do not execute raw Python. Just trying to guardrail it to see if we can get something more interesting. And what is should be happening here too is I wonder if there's an argument. Let's see if I can check this. Okay, cool. What I'm trying to elicit is, and we should see a lot of turns. Let's walk through it one by one. I ask that question, and then what I get back is the agent is trying to list files. Okay, it sees I have all these files, and it sees I have a sample data folder. Then it goes like, okay, sample data. That looks like what I need to answer the user's question, which is pretty high level. I didn't tell it where to look. It's like, sample data. Let's see what's in here. Okay. And then we return, okay, here's what's in sample data. Then what is it doing next? Okay. Next thing it wants to do is call tool. Is this right? I think this is right. Yeah. Now it's trying to write a file. And let's see where that file went. It tried to create this in got result okay. It created a requirement. And you see there's like files being created in my system. So it created this. It's like, okay, let's create a set of requirements for my script. Okay. It literally just wrote this file that wasn't there before. You're helpful, blah, blah, blah. Okay. Again, more writing. Now it's writing a Python script. So if I go through this, this is a machine learning model script. Okay. I'm going to try to open this. Let's see what it did next. We are on turn 4. We are seeing messages, blah, 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 blah. Da, 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 da. Perfect. An LLM is generating its next response. Let's take a look at this. Okay. This is what the agent wrote. Random forest regressor, gradient boosting regressor. It's writing things to do CLI arg parsing, load data, build a model, evaluate the model. It wrote all of this. I didn't do anything. Then let's see what else it wanted to write. It wrote a README. Now, I didn't add something here, which is as the agent is doing this, it's actually omitting thinking tokens too, not just kind of taking these tool actions. It's telling you kind of, oh, I should do this next. Oh, here's what I should do, blah, 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 blah. Okay, it created a nice README for me. We're on turn 5. It listed files again. Couldn't tell you why. Now, okay, it wrote a shell script now. Run RF to run the random forest model. And I presume it can't, okay, I didn't give it a tool to execute commands, but let's see how it tries to deal with that. Executing tool name readme. Okay. And let's see where we got here. Okay, I maybe just blew up my API a little bit, which is fine. And here's why it gets a little bit tricky because there's all these things you need to manage. What happened here is it tried to just raw read a file. I don't understand why. There we go. If I scroll all the way to the top, I'm used to this stuff at this point. I'm going to use my mouse. Okay. Okay. It tried to raw read this training set, which is like a no-no because what happens is this is just going to blast the context window. And we got an error from the API. If I scroll all the way down here, saying, oh, you have exceeded the maximum context window. Why? I made a big mistake and I stuffed an entire data set into context. Yeah, 830,000 tokens. Please reduce the length. Okay, fine. But let's look at what happened. I mean, it's pretty awesome. Just this very simple agent, like this very lightweight line of code, which I could augment to, get around these errors and make sure these kind of silly mistakes of content management aren't happening. From this simple query, which is please create a machine learning model to predict medium house value of California homes. Report regression metrics like MAPE on the test set. Wrote the requirements file for the script. It wrote the training script itself, which looks pretty reasonable. Load data set, right? It does all this like feature engineering. It's creating a sklearn pipeline to do column transformation, pre-process the data, create, let's say, a random forest model or a gradient boosted regressor. Creates this part of the pipeline. And let's see where it's actually trying to train it. And here's the main, okay. Parse the args, create your X train, Y train, X test, Y test, and your feature columns. Build your model, train it, fit it, predict it on the X test. This is all perfect. Evaluate it again on the test set, and then save outputs. Um, yeah, save the outputs. And then there's a shell command that comes with it. So honestly, I mean, this is pretty good. If this ran, we would have got a model that actually does everything we asked for. And we were looking at the turns, what it's kind of doing one by one. Okay, let me understand the workspace I'm in, read the files. Okay, I got it. Here's the data, here's what exists. Let me create the script to do this type of thing. Then it obviously wanted to take a look at the data and we blew up the context, but so be it. So I would definitely say try to play around with this on your own time. Um, you can do a lot of powerful stuff. You can see just files popping up. I thought that was pretty awesome. If you use more advanced tools like Cursor and Cloud Code, you'll see this stuff all the time, but let's peel back the magic. Really, this is what's happening. This is it. You can also feel free to use the Anthropic API key. You don't have to use the GPT one. Doesn't matter. Pick your favorite, pick which one you like, go for it. And I'll say, so yeah, file system tools. I think what every agent developer has basically realized is just let the agent operate on the file system. Let it read files, write files, do whatever it needs. And they can be so productive. Like again, all this work um, in such a simple kind of set of legs, tools, simple prompt, simple amount of code, boom. Yeah, so what the agent likely did that blew up its memory is it called read file on this file, on probably on this one. This thing is huge. And think about it, we have tools already to kind of manage human context. This is a huge file with, I think, 10 per page times, let's say 17,000 rows. Colab knows when I click to open this to not show me a raw text file of 17,000 rows. It's like, okay, this is huge. Let me show you 10 rows first, not kind of overwhelm your human context, which is your eyes or the entire screen. I'll give you a small preview and you can kind of navigate this preview. We need to build kind of the same content management, smart content management for our agent. So what I would do is this read file, and honestly, I'm down to run it again. My only problem is without kind of LLM augmentation, this is going to take a while. So what I'll do is this. Read file, list files, perfect. I'm just going to open ChatGPT and we augment these tools to be more robust to one, errors, so they don't crash my agent script, and two, context management. If the return of any tool is greater than, let's say, 5,000 characters, truncate it and return that the return some helpful information to the agent so we don't overwhelm the context. Uh, I'm just going to paste it in and see what happens. Okay, awesome. All right, let's try this. We'll do the same thing. Paste it in here. I won't delete it. I'll just comment it out. And I'm going to delete the things it made. So it starts from scratch. Run. Perfect. All right, let's try this again. Oops. Does not match pattern. Interesting. But why? And this is happening in run agent. Interesting. Something is wrong with, I think, the tools. Ah, I don't know why I did this. Yeah, I don't need that. All right, kicking it off again. Let's see what happens. Feels much faster this time. Last time it was unbelievably slow. Hmm, what happened this time? What gives? GPT gave me bad code. We're supposed to have limited this. Oh gosh, raw tools. Okay, raw tools. I'll edit that. Tools, perfect. And what am I passing here? Tools. Let's just make sure this is correct. Amazing. These might be pointing to the old functions potentially. Write file, read file. Interesting. Truncate, safe call. Oh, it did a whole bunch of abstractions that I got it. Okay. Okay. There we go. That looks better. Fantastic. Okay, this time we should have safe context management. There is, again, not the greatest implementation bug. As we said, the LLM will make mistakes, and I need to review it and be like, ah, that's what it did. I need to make this change to get around it. Awesome. Let me take a look at some of the Q&A. I know I've been slow on this. Can we make it to validate its outputs? Yeah, totally. So, it's kind of up to us to scaffold this. There's a lot of, let's say this, there's a lot of plumbing in agents. It's pure engineering plumbing. But when done right, they're unbelievably powerful, like Claude Code, like Cursor. Out of the box, there's a lot of rough edges, like we've been hitting. complaining about this, context management, and there's more plumbing we would need too on top of all of this. And you can see, okay, in this case, it tried to read the file, right? Sample data slash California housing train, but we truncated it, right? So that we don't overwhelm the context. And you can see every time I ask the question, it's doing something different. That's also just the reality with these systems. They're stochastic. So same question, and then now, okay, it listed files, but then this time in turn two, it decided to read the training data. Last time it actually immediately wrote, yeah, it wrote the script. So this is kind of flipped a bit, but now we see the script here. A little bit different. Okay, add features, data class, evaluate, train and eval. Okay, I'm not gonna audit it right now, but it looks reasonable. Wrote the script here. Now we are writing to, okay, now I wrote requirements.txt, created a README with a different name than before. There it is. It even saves the model as a .joblib. It's going to create this outputs directory. Fantastic. Okay, pretty cool. Pretty cool. Decided to, again, read the test CSV. Don't know why. I don't know if that's a good decision, but fine. At least, again, we have protections against not overwhelming context. And I would imagine at some point it, executes the script. Although I'm not sure if I gave it a tool to actually execute. So it might not be able to execute this. I'll have to execute it myself. Read file. Okay, for some reason it had to reread the file that I wrote. That can be dangerous too, right? Because some coding files are huge, which is why we want like smart context management. Anywho, I'll let this go on for like one or two more turns. We're gonna meet the cutoff anyway, but I'll kind of stop it there. Um, I'll just say hopefully this was interesting and motivating and giving you an idea of like what is an agent? How could you build one yourself? Well, here it is. There's a lot of simplicities in this implementation, but we just go from the top. Yeah, a lot of motivation, a lot of good tools out there to handle this stuff for you, so you don't have to worry about it. Max iterations reached. We looked at Moltbot. We looked at OpenClaw, which I definitely recommend people at least try out. It's pretty fun. You can start following it. And yes, this collab is shared. So if you go to the Q&A tab in Zoom and look at answered, it's in one of my, I think it's the first answered question. Right. Most interesting was how it created its own Python script. So yeah, this is, and again, as someone who works with like industry grade agents, I'm I expect it to write whatever files, whatever scripts it needs to get the job done. They have the kind of tools, they have the interfaces, right? They have the arms and legs to do these things. And actually, I'd say they're trained to do this now. The file system based agents is where it's at. Just write a file, execute a file, read a file. It's a really good interface. And yeah, definitely try it out. You can again try out these ones too. Where'd they go? Codex and Claude Code. Say with Claude Code. Super. I love the competition. I love it. Try it out. It's command line based, but it's super easy to use. You can also plug it into VS Code. right? You can see it in action, writing code, thinking, taking steps. It's really pretty awesome. Cool. With that, I know we're basically at 11 right now, so I'll hang around for a couple more minutes, but that's about everything. So hope you guys enjoyed. Hope you learned a lot, and have a good long weekend if you have the Monday off. Cool. Use a Cloud Code agent on the chat session. Okay, looks like okay, I'll share the collab link one more time, and then I'll also call it for the session. So this copy link done. Just one notebook, as I predicted. Did not have time to cover the other notebooks, but that's fine. All right, everybody, have a good weekend. Bye bye.